a dark streak on a planet famous for dryness. If this is water's signature, everything changes.
Robots have no feelings, but data does. And the data whispers, something Meltus. This isn't a spot, it's a line, an invitation to look deeper. On Mars, even a small anomaly can be worth an entire mission. But
because Mars still holds our biggest question. Are we alone?
and to answer, we must look farther, much farther. That dot is home, and it's where this journey began. To search for water on Mars, we had to send a machine tens of millions of kilometers.
And it began on a morning on Earth, when humans chose to reach the red planet.
Every bolt and panel exists for one purpose: deliver a robot where humans can't stay long. The rover is folded like a secret, waiting to unfold on Mars. A tiny error, and the whole journey vanishes into silence.
And then, the moment of leaving the ground arrives.
Thousands of people, millions of calculations, compressed into one ignition. One quiet second before Earth shakes. Fly. Fly to search for a drop of water where no one can touch. As we rise, the sky changes and distance becomes real.
From here, home looks unbelievably fragile.
Each separation is a promise. We're still on course. The rover sees space first, before it ever sees Mars. Power for the entire journey comes from the sun itself. Ahead is emptiness and a red point waiting. This journey isn't fast. It's patience written in orbits.
We leave the familiar for what we've never touched.
Each planet is a world, yet our destination is the red one. Between worlds, rocks, emptiness, and math-made paths. Jupiter reminds us, the solar system is far larger than we feel. We're bending our orbit to meet a red point on time.
Mars has an atmosphere.
From orbit, bright patches, polar ice, hints of water. A Martian day is slightly longer than Earth's, called a sol. Mars has two tiny moons, Phobos and Deimos, like two watchful stones. Tiny, but enough to remind us, this place is unlike anywhere else. We aim for places that once flowed, because they once had life potential. Thin air means cold, warmer by day, plunging at night. Right now, cloth and a few engines hold the entire mission. We're about to touch down, by robot, not by human feet. And this is the moment. Mars receives a new visitor. Touchdown confirmed. From here, discovery begins with a wheel track.
The robot begins to fee on our behalf.
This dust records every move, like a planet's diary. Mars is vast and empty, so every small sign matters. We go where water once moved, because it writes stories in stone. These layers are pages, each one a chapter of climate.
This arm will touch what humans can only imagine.
Martian soil is dry, yet it can hide salts, ice, and faint moisture.
Thin air lets dust travel easily, painting the sky.
And here is the clue that pulled us across space. If water exists, it may appear as thin films, melting ice, or salty brines. One blue dot, holding all the life we know.
Mars is the fourth planet from the Sun. Cold, dusty, yet once watery.
A Martian day is about 24-hour, 39 meters. Mars's atmosphere is about 1% of Earth's, so it can't hold heat well. Light here feels different. Dust scatters it. Less glare, more chill. In favorable spots, day temps can near 0 degrees Celsius, but nights can drop to -70 degrees. At the poles, water ice and seasonal sea-soat ice, a gigantic freezer. Mars has 4 seasons, but longer. Its year is almost twice Earth's.
Dust devils are common on Mars, like sweepers that reveal or bury tracks. Sometimes dust storms spread planet-wide, forcing rovers to sleep to save power.
From above, Mars has weather, even without Earth-like rain.
Dust is both enemy and evidence. It records and erases.
So where could water signs come from? We must read rocks, salt. These curves resemble dry rivers, signatures of ancient water. Layered sediments often require long-lived flowing water. Why deltas excite scientists. Salts can keep water as brines at low temperatures, chemistry's trick. In many places, ice lies just beneath the dust, water hidden away.
Water doesn't guarantee life, but it opens the door to the possibility.
Olympus Mons is the solar system's largest volcano, towering above Everest. Its slopes are gentle because it's enormous, hundreds of kilometers to feel the climb.
The summit holds multiple nested calderas, scars of ancient eruptions. And this is Valles Marineris, an immense canyon like a planetary cut. It stretches thousands of kilometers, one of the biggest structures we know.
Here you'd feel as small as dust, because you are.
These layers store memories of stress, fractures, and time. Mars isn't just sand, it's geology as a history book.
Volcanic rocks say Mars was once hotter and more active. Craters are everywhere, time marks on a surface not erased by rain.
On Earth, wind and water erase faster. On Mars, traces can linger longer. The rover's job is to read those traces and tell us the story. Phobos orbits very close. One day, it may break into a ring.
Deimos is smaller and farther, like a quiet companion.
Without a strong global magnetic field, Mars struggles to keep its air from the solar wind. Earth's magnetosphere is a shield. Mars doesn't have a big one like that. Over time, the atmosphere thinned and the planet cooled.
That's why liquid water struggles to last, yet traces can appear briefly.
From the red planet, Earth looks tiny, but its meaning is immense. Now we don't just look. We sample, to learn what the streak truly is.
A tiny grain can hold a big answer.
Mars isn't loud, it's quiet, and that quiet helps us listen. Thin air makes the sky clearer, and distance feels more real. Sometimes the solar wind paints fragile light across the Martian sky. From a dark streak, we traveled through a whole system of questions. And this planet still holds millions of unopened secrets. Remember, big questions begin with the courage to look far. But Mars's story doesn't end here. We still need to understand how it works. Mars's air is mostly COCC, with almost no breathable oxygen. Pressure is so low, liquid water struggles to persist. It evaporates or freezes easily. Mars's gravity is about 1/3 of Earth's. Things fall more slowly. Fine dust clings stubbornly, a major challenge for long missions. Drilling into rock is drilling into time, searching for water, salts, and chemistry. Samples are stored like treasure. Some may return to Earth one day. Driving a rover isn't like remote control. Signals can take minutes to arrive. Night falls fast and cold. Rare moisture can freeze into frost. Some salts, like perchlorates, can allow brief, briny liquids. Sometimes methane is detected. It could be from rocks, or something more intriguing, still uncertain. Many places were once lakes, and lakes preserve chemistry best. In thin air, flying is hard, yet a tiny helicopter proved it, unlocking new perspectives. From above, we pick safer paths and spot structures we might miss from the ground. One day, humans may come. But first, robots must scout and sign. From a dark streak on red soil, we learn something bigger. Space is vast, but curiosity is vaster. And if you want to go farther, next time we'll visit Jupiter and its icy moons that may hide oceans.